Do you know how long Magnus Carlsen, the best chess player in the world, has spent playing the game? Well, it's tens of thousands of hours, and that's good for him, but I want to be good at chess too. And I don't have that kind of time. Magnus? Why can't I be like him? Why can't I... Wait. It's genius, really. What are they gonna say? Take off your glasses? Play blind? No. This is the plan. I have a Raspberry Pi 02W. I'm gonna set it up, hook up this webcam, and somehow use computer vision to detect the chessboard and the piece positions on the board. That output will be sent into a chess engine that finds the best move and sends it into a speaker that sits right by my ear. Then I add power, throw it all on a pair of glasses, and without anyone even noticing, I'll become the greatest chess player of all time. Computer vision is what it sounds like. You give a computer eyes. It's a branch of AI focused on getting computers to interpret what they see. It's what ChatGPT does when you send it a photo and ask for advice. Detecting the state of a chessboard, especially with how powerful AI is now, doesn't seem like that much of a challenge. And it's not, if you sell your kidney and rent out a warehouse of GPUs, but I'd rather keep my organs, and there's actually a lot of interesting work being done in this space. Researching for this video, some of the coolest stuff I found was from Chessboard Sam. I thought that hearing from somebody that actually knows the space would be a lot better than going into this blind, so I sent him an email and he was down to talk.
Well, nice to meet you. My name's Sam. I used to work in Google Research in the past. Now I'm doing consulting on my own. For me, it's always been kind of a hobby to explore the different algorithms for the chessboard detection. There's different approaches. You can use pure computer vision, you can use computer vision plus ML, you can do pure ML. The moment you introduce real time, you start to have to choose more efficient algorithms, which tends to be computer vision right now. There's some things that you could do really easily. Like if you're just trying to find a thing that looks like a piece on a board, you can use YOLO or RFDeter, all these other ML algorithms to find and put a bounding box around these things, or even a segmentation. That is actually something very powerful about AI nowadays. There's a little bit of a difference between figuring out what pixel is what class, which is kind of what these things do to a different degree, and having a world understanding or 3D understanding about the world space.
Given enough data and compute, at this point, it's not hard to predict things. That's what these models are, they're predictors. But to actually understand something, to know what's going on and when something goes out of frame to know where it went, that's something these models can't really do yet. They can try to fill in the gaps, but at a cost.
AI is still super computationally expensive, so if you're trying to do anything real time, like say cheating with a chessboard camera, if you try to run a full-size ML model at that, 10 FPS even, you would have a pretty hard time doing that. And so you want to make the problem simpler. And this is kind of where using math and algorithms, such as in the field of computer vision, can help a lot.
The Raspberry Pi is basically a cheap, tiny computer that runs Linux and has Wi-Fi built in. The Pi is going to be the brain of the glasses. To set it up, I install the OS, enabling Wi-Fi and SSH, which allows me to talk to the Pi wirelessly through my laptop. Then I run this extremely complex query and put in my secret code, and that's it. I picked this camera off Amazon because it's a laptop webcam, so it can sit across the bridge of the glasses. I connected it to the Pi and tested it, and it worked. So with the Pi and camera ready to go, it's computer vision time. I wanted to make it work on a single image first. Board detection seemed like the clear first step, so I tried training on a public dataset to detect board corners, and it didn't work. Then I remembered Chessboard Sam already spent years solving these problems. One of the solutions he found for detecting chessboards was to use harmonics, essentially detecting the repeating structure of the chessboard in the image through clusters.
The true grid pattern has a unique fingerprint that noise can't replicate. They create strong repeating signals at integer multiples, which feels very similar to the harmonics of sound waves in music and Fourier space.
It worked very well. It also warps the board into a grid, which makes change detection easier later on. So now for piece detection, I need data. So for the highest accuracy, I needed to take images of my board and hand label every single piece. I decided this dataset would work. The accuracy turned out pretty high on the test set, but there was an issue. I was trying to detect the board, warp the board, and then detect the pieces on that warped board. But as you can see, it detected almost none of the pieces, and many of them were cut off at the end of the board. The approach of warping and cropping before detecting pieces was obviously stupid and not going to work. Instead, I decided to train the model to detect pieces separately, then do the detection on the images before warping, tracking the coordinates of the bottom of each bounding box before and after the warp transformation. Each piece would be placed in the grid square with the nearest center to the tracked coordinates. I added this dataset and started training. It looked good. It was getting the pieces correct almost all the time, so it was time to test on my images using my webcam, board, and angle. I did like 10 images and most of them were like this. The accuracy when it detects the piece is fairly good, but it misses a lot of the pieces and misdetects some of them. When feeding the game state into the algorithm, even one mistake ruins the output. I'm stuck. I have two choices. Label my own data and try to improve the model, or abandon it altogether and start fresh. I'd asked Sam if he had any general advice for building things and doing projects. This is what he had told me.
Don't get stuck on one approach. Try to think of at least 2 or 3 different ways you could solve this same problem. And if it's easy enough to do, try all of them. Because I've found, for me at least, I think I have the best idea at first, and then I try it and I try a bunch of others and I realize, oh, I was actually dumb. And it turned out these other approaches are way better. So I think that can happen a lot. We can kind of get tunnel vision thinking we have the best answer immediately. It's a lot more fun, and it is research really to try different approaches and see which one wins.
I was actually dumb. New idea. We go back to using the warped image grids we already have, saving the first one as the initial state, and we detect changes on the grid. If a pawn moves from d2 to d4, the change in light and other things in those 2 squares is going to be a lot higher than in other squares on the board. The squares with the highest change can be checked against chess rules, applying the move with the highest score to the board. The first thing I needed to deal with was orientations. The warped board is not always facing the same direction, so I needed to normalize each image to the state most similar to the last one. To make sure the white was at the bottom in the first image, I used the lightest and darkest square, putting the lightest bottom right and darkest top right. I tried using change in edge detection first, and that picked up really well. I added change in light and hue, and after a lot of testing, I came up with this equation. And I got it to predict all the right moves on my initial set of 8. I then added stockfish integration to give the best responding move. I'm not actually putting it together yet, but I do need the camera on the glasses. So I have the webcam, tape, scissors, glasses. I'm just gonna put it across the middle and then tape both ends. There we go. Now, why didn't I use clear tape? It's because I can't think ahead. What do you think about it, Chess? I had to test on more data before live integration, so I took pictures playing against myself. Equipping the glasses. And after every move, take a new picture. Just like Magnus Carlsen said.
Sit at the chessboard and play with yourself. It's amazing. Okay.
My head is gonna explode. Now, running my data on this, it was doing pretty well. It would always get the first few moves, but eventually it would get one wrong. And the issue with that is one incorrect move means it's wrong for the rest of the match. So I need a simplifier. I've been trying to detect every single move up till now, but when I run this live, I'm gonna be doing whatever it tells me. I can't think for myself. If it knows where opponent pieces are, it can check those squares for changes. So I decided to take more images and test the algorithm on those, correcting each image it gets wrong and saving the correct solution for each image pair as the ground truth. It knows the truth for the first of each pair and guesses for the second. Time to run it back.
Sit at the chessboard.
I added a bunch of rules to deal with pieces bleeding, which was by far the biggest issue I faced. And eventually on the 2 games I recorded, I was getting like 90% accuracy on average. Getting 100% every single time was obviously not going to happen. There's too many other factors involved relying on lighting and edge detection, so I decided to add a button. If I have a button in my pocket, it simplifies this in 2 ways. I can press it to take images after the opponent moves, and I can press it twice if what it predicts is incorrect. If it's wrong and I press the button twice, it'll check the next best scoring option. If it's wrong again, I press the button again, and so on. That way it'd be practically impossible to mess up. Right? I was at the point where wrong answers were rare. I was happy with this, and I got the audio working, so it was time to live test the code. Here we are.
Initial board state detected. You are white. Best move, pawn to e4. Your move, pawn e2 to e3.
Oh, for real this time.
Pawn to e4. Opponent, pawn e7 to e6. Second best, pawn e7 to e5. Hand in frame. Wait for pieces to settle and retake. Hand in frame. Hand in frame.
I made some other adjustments. I can now get the correct move on the first try almost every single time, and otherwise one of the next few. Now that the code was all ready, it was time to put it together. Small issue though, I don't know how. So I studied and learned, kind of. Okay, that went great, no problems, incredibly neat connections. I'm not going to show you though. The parts are together now. The speaker's attached, the button's attached as well. This should talk. Everything had worked.
Best move, pawn to e4. Opponent pawn c7 to c5. Best response, knight to f3.
See to the chess.
Best response, pawn to h3.
Did he say H2 or H3? Wait, that's pretty good. I'm like actually ready to put it all on the glasses. Putting the glasses together was my last step to become a grandmaster. So I've got everything here. It's time to actually build it. I first needed to attach the camera through the power of zip ties. That works way better than I thought it would. Then I coiled up the cord using this plastic thing because it was too long. This might light on fire while it's on my head. That would not be ideal. Yeah, good call. I then superglued the Pi onto the side of the glasses. Getting a little heavy. Next, I glued the speaker near where my ear would be. To my surprise, it was perfect. Well, that's perfect. All right, I'm gonna plug everything in for now. And this will go in my pocket along with the button. I did some cable management. Now came the test. So the speaker worked, the button worked because I had to press the button. It's finally built. Here is the build. And with a keen eye, if you look closely, you just might be able to tell these are not actually normal glasses. After hours and hours of work, I was ready. This might be the fastest elo climb the world of chess has ever seen. I'm gonna play against two of my friends. The first one, Adonis, he knows what I was building. The second, Dan, he's a pretty big fan of chess and we play a lot and we're always pretty even. Until today. He has no idea what I built. And since they're practically indistinguishable from normal glasses, he may never know. Adonis is a chess grandmaster. And so we're gonna be 1v1ing today. I just need my glasses.
Yeah, of course.
Hold on.
Yeah, something's a little funny. New prescription?
Yeah, it's updated. I see really well.
Okay.
I'm gonna go pawn d7 to d6.
Why would you ever do that move?
You know, don't ask me.
We can always retreat.
Awful move. What? Pawn d7 to d5? That doesn't make sense.
Just move d6 to d5 and call it.
You know what? That's true. So I hit the wrong button. Basically, I accepted the wrong move at some point, and so it was all messed up. I kept using the glasses to move until it wasn't possible. I unfortunately ended up having to use my head.
Let's get some motion. The pieces are speaking to me, I think.
No, they're speaking to me. Check, buddy.
I'm gonna delay the inevitable.
Oh shit. That's
yeah, I
the
wonder how you
first
came up with
piece.
that move.
I thought really hard about it. Holy shit, I pressed the wrong button.
What are you talking about?
Mentally.
Mentally.
That makes sense.
What is this move?
My vision is clear.
Let me be clear. Moving a good bit faster now, aren't we? I'm fine with that. I don't think I can do anything, bro.
You've got one move. Check.
Oh, shit.
Oh, thank you.
GG.
Good game. That was hard fought, fair victory.
I mean, it was
Yeah.
pretty fair.
After a little bit.
After a little bit of
cheating. After a little bit of cheating. But despite the questionable finish, I had won the game. The glasses worked. That meant it was time to play Dan. Since I told him I'd been working on a project, I decided to convince him I was just practicing chess the whole time. We're playing chess. But I practiced. I've gotten better.
You have?
I have. Let me just put on my glasses. What the fuck? What, bro? They're my glasses.
All right, sure.
He didn't suspect a thing. Now I just needed to trust the glasses to do the rest.
Oh, shit.
Yeah, I had that planned.
That mate. Yeah.
GG.
Damn.
It's okay, bro. Honestly, your only chance was to make me confused and accidentally hit the button.
Yeah. GG's. The bot won.
He had no idea. He had no idea. I mean, I can't blame him. Not even Hans Niemann was this discreet. Dan, if you're watching this, I'm sorry for deceiving you. Basically, I beat chess. It's a solved game. But computer vision wise, this is just a tiny example of what it can do. Recently, the progress has been insane. Sam told me about some of the cool things happening in the field.
I remember when I was going to college for robotics and then working in robotics, we do a lot of handcrafted algorithms to teach a robot how to grasp a mug in a certain angle, and then you have to modify the algorithm or create a new one to grab a pencil or scissors. All of it is just a bunch of hacks upon hacks upon hacks, and you can't, as a human, really write enough code to cover the whole world. All of a sudden, you can throw an ML model at hand grasping, for example, and it just works on everything. It's not just, it does an insane amount of work and research, and it's still making this possible, but the idea that we might not actually handcraft these algorithms anymore, we can train models to just use computer vision to kind of see the world and push and pull on objects, just like we human babies do, you know? I'm sure we're going to be seeing some incredible progress there. Despite the incredible power of AI, there's still math, there's still algorithms, there's still this concept of completeness, satisfiability, all these things that you learn in robotics that will be applied to machine learning. Machine learning is still a tool inside the computer vision toolbox, let's say, and you want to make sure you understand how your tool works and you use it well, and it is part of a system. And so as a student or anyone going into this field, I think understanding that it isn't the whole thing by itself. You gotta have all the other parts to go with it. And the people who know how to do that, they crush it, and they make all these amazing companies and all these cool things. It's always fun to see.
Check out Sam's work in the description. If you want my code, you should probably get a job. Let me know what I should build next. I don't know how do you make an outro? But that's about it. See ya.